So in this question, we are given this wave function, psi, and so psi is equal to a e to the 2 pi I x over lambda e to the minus 2 pi I nu t. There are a lot of things in this which are just going to be constants. And so that's something that I'm kind of should always be aware of. Actually, it might look complicated, but it's not as complicated as it first looks. So we're asked to determine the momentum, the px of this, where px is minus ih over 2 pi d psi by dx. So the first thing I want to do is I want to differentiate my my wave function here with respect to x. So I'm differentiating e to the ax essentially. I've got a whole heap of constants which are unchanged, so I'm going to write in first off my constants that are unchanged because they're multiplicative constants, they will stay there. And then I have to differentiate, this term here is the only term which contains the x, and so I'm going to differentiate e to the ax essentially, where a is my 2 pi I over lambda. And so if I differentiate e to the ax, I get a e to the ax, and so that means that my 2 pi I over lambda is going to be now multiplied by everything, and my e to the ax itself remains unchanged. And so here what we can notice is the differential of this this wave function is actually 2 pi I over lambda times the wave function. I can simplify it all the way down to that. Now I'm told that my momentum is equal to minus I h over 2 pi multiplied by my differential, which I have been worked out already, which is 2 pi I over lambda times psi. And I can do a little bit of cancelling. 2 pi cancels here, 2 pi cancels here, which leaves me with an answer of minus I squared h over lambda multiplied by my wave function. Now, we haven't yet covered in this course this term I, but just as a note, I squared is equal to minus 1. And so I can simplify this further if I want to have I squared is equal to minus 1. Minus I squared therefore has to be equal to 1, which is equal to h over lambda times my wave function. Now I will make a note just here to say that this is a slightly simplified version of what goes on in quantum mechanics. When you do this, you'll find that actually that for reasons that I've not shown, the psi cancels, and so you get down to a de Broglie relationship, which you might have seen elsewhere. But this was a maths question. I set it up just as a maths question, and so for me, this answer is good enough.